All right, let's dive into a Python concept that trips up even seasoned developers, especially in technical interviews: advanced scope. Getting this right is the absolute key to writing cleaner, safer code, particularly when you start tackling recursion and complex data structures. So let's get into it.
Okay, take a look at this. At first glance, this seems like it should be totally fine, right? We've got a global variable x set to 10, and inside the function, we're just adding 1 to it and printing it out. Seems simple enough. But if you actually run this code, it doesn't print 11, it just crashes. So what is going on here? Why does Python throw a big error instead of doing the one thing that seems so obvious? And this is what you get, the dreaded unbound local error. Understanding why this specific error happens is no joke the secret to mastering Python's scope and acing those really tricky interview questions.
Here is the absolute key. Python figures out the scope of variables when it first compiles the function, not when it runs it. So it scans the function and sees an assignment, that x equals part, and because of that, it decides, okay, x is a local variable for this entire function. Then, when the function actually runs, it tries to read the local x on the right side of the plus sign before a value has been assigned to it. And boom, that's the unbound local error.
Now, your first thought might be, ooh, I'll just use the global keyword. I mean, it seems like it was made for this exact problem. But let's dig into why that is often a really dangerous path and a major red flag in both production code and interviews.
The global keyword is basically a direct order to Python. You're telling it, hey, listen, for this function, when I say x, I am not talking about a new local variable. I want you to reach all the way out to the main module-level scope and mess with that x. And as you can see, it works. Problem solved, right? Well, not so fast.
You see, using global is a trap. It makes your functions impure, which is a fancy way of saying their output now depends on something hidden outside of them. This makes them unpredictable, a total nightmare to test, and it completely shatters the model of clean, reliable recursion. Honestly, it's a huge code smell that interviewers spot a mile away.
So if global is the wrong tool for the job, what's the right one? Well, let's move on to a much more elegant and powerful way to handle this: the non-local keyword and this awesome concept called closures. This is how you build a much better foundation.
Think of it like this. Non-local is the surgical tool where global is a sledgehammer. It's designed specifically for nested functions. It lets an inner function reach out and modify a variable from the function that's directly wrapped around it without ever touching the global scope.
And this comparison here is really what it's all about. Global just punches a hole all the way out to the main module, which can affect anything and everything. Non-local, on the other hand, just cleanly and safely modifies the state of its immediate parent. That precision is what enables advanced, clean patterns like decorators and closures. And that leads us right to one of Python's most powerful and kind of magical features, a closure. The easiest way to think about a closure is as a function that has a memory. It's a function that remembers the environment, all the variables, where it was created, even long after that environment is gone. This process is just brilliant. Look, the outer function, multiplier, it runs, and then it's done. But right before it disappears, it returns the inner function. And that inner function, it carries a backpack, so to speak, and inside that backpack is the variable x from its original home. That state is preserved, locked right inside the closure.
And when you put closures and the non-local keyword together, you can create these incredibly useful stateful functions that don't mess up the global scope at all. This make counter function creates a totally independent counter. Every time you call the increment function it returns, it remembers and updates its own private count variable. This is perfect for things like caching, decorators, or just managing state cleanly.
Okay, now that we have the right tools, let's talk about two silent killers that trip up even really good developers: variable shadowing and the infamous loop closure trap. These are classic interview gotchas.
Shadowing is actually pretty simple, but it's dangerous. It's when you create a local variable that has the exact same name as a global one or one in an enclosing scope. Inside that function, the local name wins. It takes precedence, basically hiding the outer variable from view. This can lead to some really subtle and frustrating bugs.
And now for the big one, a true classic interview trap. We're creating a bunch of little lambda functions in a loop, and you would totally expect each one to remember the value of I for that specific iteration, right? But here's the catch. Closures capture the variable itself, not its value at that moment. So all three functions end up pointing to the very same I, which, after the loop finishes, has a final value of 2.
The fix for this is so clever and elegant. By making I a default argument to the lambda, that little I equals I part, you force Python to evaluate and store the current value of the loop variable right at the moment the function is defined. Default arguments get evaluated once when the function is created, not when it's called. This trick effectively freezes the value, so each function gets its own correct copy.
Okay, let's pull all of this together into a practical checklist. This is the mental model you should be using to debug your code and just absolutely crush any scope-related questions in an interview. Seriously, before you write or debug your code, just run through these questions. This is really just applying Python's LEGB rule: local, enclosing, global, and built-in. Ask yourself, am I accidentally shadowing something? Am I modifying a list, which is mutable and doesn't need nonlocal, or an integer, which is immutable and does? And please, whatever you do, never, ever name your variables list or sum. You'll hide the built-in functions and cause total chaos.
And please, remember this golden rule, especially for data structures and algorithms. Recursion must be pure. A pure function's output depends only on its inputs. It doesn't rely on some hidden external state. It gets its job done by passing state through arguments and return values, creating fresh local variables for every single call. If you find yourself reaching for a global to track something in a recursive function, just stop. Your design is almost certainly flawed.
So let's come full circle, back to our original problem. Looking at this code now with everything we've covered, you know exactly why this raises an unbound local error. Python sees that assignment, it flags x as local for the entire function, and then it tries to read that local x before it's ever been given a value. It all makes sense now.
So by really getting a handle on compile time scope, the huge difference between global and non-local, and the power of closures, you've really gone from being confused by Python's weird behavior to being in complete control of it. You're now ready to write way safer, cleaner, and more predictable code. If this finally clicked for you, comment LEGB below if you watched till the end, and definitely subscribe for more deep dives into Python mastery.